Hello, my name is Rich Howard, owner of Architectural Builder Supply. So this CNC project is creating on the tool a platform onto which to set an air handler. And an air handler is nothing other than a rectangular box that's got a um, motor in it that has a hamster wheel sort of airflow uh, creation so that you can suck air through a filter. And I own whatever, a couple, three of them, and I use them just to help keep the quality of the air better. Well, I've been noticing where a lot of the particulate ends up is obviously on the floor, ultimately below the table and on the sides of the table. So because I have an extra air handler, I've got one above the tool. I've got obviously dust collection on the tool, and I'm going to place a spare air handler underneath the tool just to help. It's like if you spend 1 hour cutting, you spend 3 hours cleaning, is what I'm finding. I have an uncle who is, he's a boat captain for decades, and it's like you own a boat and you spend 10 hours cleaning it and 1 hour enjoying it. So I'm realizing there's a correlation, a lot of cleanup time. So trying to reduce that. So let's move on with what we're going to create. Let's do that right now. Okay, so here is what we are working on, and the air handler that I referred to is hanging up there in the ceiling, and I'm quite sure that Delta discontinued these, and you can get them by other people, but to me they're really great. And I don't buy the manufacturer's filters, they're just far too expensive. I get filters from the local home improvement center, and my spare air handler I have here, and what I was referring to was that sort of hamster wheel type of motor that's there. And we'll turn this on. I mean, you probably are quite familiar with it, but maybe you're not. And I enjoy that running because I know for a fact, just by looking at the filter, it does help keep the shop clean. That filter is not black, but it's a lot darker than it was a month ago. Okay, so what I'm doing here is I'm going to be placing the unit below the work table, and I'm going to be placing it on top of the steel platforms that are here, the steel L angles. I'm going to drop it right on top. I'm going to notch the side of it around my PVC for the Becker that's here. I'm going to create the height of this such that my Roombas can get underneath, because Roombas actually work pretty well for sawdust. You would think that they wouldn't, but they'll do it. It's not awful. I do have them and I do like them, so I'm going to use them. I'll make it so that they can get underneath here to clean all that up. I'm also going to have a piece of 1/8 inch neoprene, self-adhesive neoprene, that will sit here so that when it's on, it doesn't cause substantial vibration. Now that is an unknown, and it may not work. This might cause too much vibration, but I've decided to not hang it from the underside of the tool because I thought for sure that would create too much vibration. We're going to see. It's an experiment. We'll know when we start cutting material. So what I have come up with is, this is a piece of 7/16 OSB. This is going to actually be the bottom of the material. So I've glued a piece of 7/16 OSB to a piece of 3/4 MDF and then to a piece of 3/4 plywood. The plywood will be the top, and that's what the tool will sit on. And I'm going to pocket into this so that the Roomba, the height will fit underneath here, so to be able to collect. I don't want there to be a infinite collection of particle board underneath my platform. And I'll be pocketing into this material to give myself the dimension needed. I've got the tool zeroed, and the Z is 4 inch. I don't know how much more room I've got on the Z, but at 4 inch where I am now, I know that my bit will be of the proper length to be able to get down into the depth that I need, which is, because I'm going to profile cut this to the size 3/4. Oh, I want to get that out of there. 3/4 plus 7/16, 1.5 nominally. So so nominally 1 and 15/16. So it's pretty thick material. It's very heavy. We're going to see what happens. And right now we're going to change the bit, and let's do that and see if we can zero the bit. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now let's get back to it. All right, let's get the proper cutter installed, because the Z-axis was not responding to me. I had to turn off the controller. I've got a chip breaker here. I'm just going to make sure it's got the right amount of length. Yeah, and it does actually. This should work reasonably well for us. Let's take a look. Yeah, I've got a compression bit, an Onsrud 60-172 MW. That's going to be the bit we'll use because it's got a better cutting length than the 60-951. It just doesn't have the right length for what I want to do. In a future project, I'm going to make a tool holder. So we're going to need a 1/2-inch collet. These collets really get wood packed in them, and Onsrud sells brushes and whatnot, which I'm starting to think is going to be a good idea, because it's hard to get that clean with a fingernail. It does get in there, is the bottom line. So let's snap our collet in place. Let's get that threaded up. We'll get the bit put in place, and then obviously I'm not going to bother zeroing it, because the bottom line is I'm going to have to tool path this first. And the machine, the point is the machine will be turned off before we would cut any parts. Probably move the metal out of the way. It only bounced twice. Okay, so the next part of this video is going to be beginning the tool path process, so let's move to do that right now. You know what's worse than not knowing where to put the neutral leg on a 3-phase high voltage panel? It's not participating in the Architectural Builder Supply March giveaway. Okay, so the next step of what we're doing here is creating the tool path, and we're going to go about doing that. So I've measured what actually will be the depth, and the depth is, well, we're just going to call it the width. So we know that we've got, I'm going to set up a guideline at 2-inch, and then another one at 60 relative to guide, one guide at relative 61.5, because that's going to be what is the depth of our unit. And actually, I'm going to take a photograph of it so we can look at that as we move along. Yeah, so 61.5 is going to be the overall depth, and I'll show that to you. Okay, created one by mistake. So 43.25 is going to be what the width is going to be. So we'll put a guideline at 2-inch, and then we'll create another one at 41.25. So now what we have here is, on my workpiece that's on the table, this is the it's rotated 90 degrees, let's say counterclockwise. I'm sitting over here. My reference is here. This is 43 1/4. Uh, it's not. Yeah, okay. So 45 1/4. Close. This should also be 65 1/2. Let's double check those. Needs to be 43 1/4 wide. Then it needs to be 63 1/2. And that's going to line up with what we're doing. And here is the space that we're working in. That's the 63 1/2. This is the 43 1/4. So we'll have that there to refer to time and again, I suppose. So we're going to need a pocket, because I'm going to be, I would imagine that I've already shown this. Actually, I'm quite sure that I have. And what we're basically going to create is something that's going to be roughly all right, line. It's going to be about, just generally speaking, it's going to look something not unlike this. 63 1/2. Okay. We're going to come down 2, even though it's 1 5/16. We're going to come over. I'm just going to eyeball it at about 3 inch. We're going to come up about 3/4, 0.75. I don't remember the exact math. What was that, 3 inch? So 60 1/2, maybe 60.5. Nope, maybe 57.5. Yeah, that makes sense. Oops, 57.5. We're going to come down that 0.75, and then we're going to come over. So this is what it's going to look like. This is what we're creating. Underneath here, I'm going to have some neoprene applied to the bottom so that it vibrates less on the tool. And I'm creating the pocket. So I want the platform durable enough to not only hold the air handler, but let's face it, it's going to end up being a shelf. So, at least to a certain degree. But I'm also pocketing the underneath so that my Roomba can get underneath, because I need a 4-inch clear distance. So the floor is going to be, somewhere in here, approximately. And then the bracket from the machine is going to be in here like this, that it's going to sit on both sides. That's the floor, that's my bracket, the neoprene will be in here, and my Roomba will be able to scooch right in here. Okay, so we're going to need, obviously, a profile, but let's work in reverse. We're going to want to pocket all this first. And I realize that I could have built this a lot easier without having to pocket a substantial amount of material. I get that. I want to do it as not only a drawing exercise, but as a learning exercise. So that's what we're going for with this. So what we need to do, I suppose, is to determine where our pocket profile is going to be. And that's going to be just knowing the dimension of the leg. How far over do we want that to occur? It needs to be inside of here, not out here. right near where it's going to be. And there'll have to be some tweaks, I imagine, that I make along the way to this. So I'm going to measure that angle. Yeah, we'll make it 2.5. Okay, so let's go with, and what I'm referring to again is this dimension right here. So let's come up with a relative guide 2.5, create new guide, close, relative guide, home, negative, enter, create new guide, close. So our pocket profile is going to be all of this, and it'll be, I'll have to measure it, but it's 3/4, 7/8 deep. So now what I have to make sure is, wait a minute. No, I drew that wrong. You guys were supposed to catch me. I drew that wrong. It has to be over here. Relative, create new guide, close, relative, create new guide, close. So now this dimension, which I'm coming up with 38.25, I'm going to measure the inside width of that now. Yeah, it's a 1/4 inch off in each dimension, so I'm going to tighten it up. 42.5, that scooches it down, close. 4.75. Now it should be 37.75. That would really be the inside dimension of our angles. So we're going to flush it to this. Let's measure that. 37.75. Yeah, perfect. Now the length's no big deal because we're going to come right off. This guideline is, we're going to pocket all the way out. This guideline is here for our profile, and we'll profile last. So what we're going to do first is we're going to pocket all of this. But I know I'm going to have to make some accommodations on the material for the bolts. Well, you know what I think I should do is make the accommodation now. So these bolts stick in my way. My material is going to bump into this. I think what I need to do is reduce my length to fit inside of those bolts, because otherwise it's not going to work. Plus, I have to chop around where my PVC is for the Becker hold down. So we're going to modify that pocketing as well. So let me measure the distance between the bolts, and that's going to tighten up. It's going to tighten up this dimension, because otherwise I need to get in here and notch that. And you know what? That's just what we'll do. We'll notch it. Why make it all smaller and tighter? Yeah, so it's going to be 1.75 inch, and then 1/2 inch deep, or reducing it by 1/2 inch on each side. So we're going to go relative guide, -1.5, close, relative guide, 1.5. That'll give us a notch. Then we're going to need a 1/2 inch. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. That's going to be -0.5, relative, create, close. This is going to have to be relative positive 0.5, create, close. So I think what I'm seeing is, and I'm just going to draw this so that we have it, is something that's going to be like, so the pocket does not need to be accommodated or notched for that. So the pocket's going to be the 37, and I think I said 3/4. And then the length of 60, of whatever that length is, 63.5. Could easily put some dimensions on here. 63 and a half, yeah. So our pocket will be that length. And then our pocket will be 37 and 3/4. Okay, so that's all of our pocket. Let's get rid of those added guidelines. Let's draw what we think our pocket's going to have to look like after we get rid of the additional guidelines. 37 and 3/4, yes. 63 and a half, yes. Okay, so now we know we've got it. Let's draw a pocketing profile. Okay, yeah, it's going to pocket all the way to the outside. I'm going to want this actually to come out another 3/8. Otherwise, I'm going to leave a weird little artifact out here, I believe. It'll end up looking something like it's going to end up looking like that, right? So we don't want that. So we're going to breach through. Let's end up changing that. Let's move this pocket. Sorry, new position 1.58, 625. Sorry. Apply. Close. 7/8, 875. Apply. Okay, now that should be our pocket. That should get us completely off the workpiece. But let's put back our original guidelines. Okay. So our pocket should look something like this. Okay, after a little bit of node editing, we have one open vector, 0.1, join, 0.01, join. And it appears as if we have a closed vector. One closed vector. Okay, we're in good shape. So now that a closed vector means you've got a toolpath that it will understand. So let's throw our guidelines back there. I'm seeing a nice pocket profile because we want the tool to come off the workpiece to clean all that out on both ends. This is going to be our pocket profile. And we can profile from the underside of the material. We can profile cut. The workpiece is laying upside down. That's because we want to profile on this side. What I don't want to do is turn the workpiece over and prep on the top of it because we will have pocketed out so much of the material here, and I don't know what that would do really because of its weight. So what I'm going to do is put the pocket profile on its own layer. Move to layer, new layer, pocket toolpath. Okay. Pocket toolpath is on. We'll leave layer 1. There's currently nothing on. Actually, we'll draw on layer 1, and that's how we will then move it to where we need to. We're going to have a profile toolpath, but we're going to have to notch it slightly. Let's draw a profile toolpath. I drew it to the outside, which is not what we want. We want it on the inside of what is our Y, well, our X, forgive me. And that'll be a profile. The issue is, though, we're going to need to notch this. So we're going to pocket first, we're going to notch, and then we're going to profile last. Because through the pocket procedure is how I'm going to mechanically hold this down. My tool will be quite far away from the outside corners. I'm going to screw that down to my spoil board, even though this thing is so heavy, it's not really going to move. So we're on layer 1. Let's take our profile, move to layer, new layer, profile, tool path. Okay. Now on layer 1, we've got nothing. Got our pocket and our profile. And that does kind of look like what I'm expecting it to look like. Now, we have to figure out what these notches are going to be. Certainly over here, because I have to get around my PVC ductwork. So there's going to be another, we're going to pocket that whole thing. Are we going to pocket it? The profile toolpath is actually not correct. It's not complete, I should say. And in fact, it's premature. So what we need to do is we're going to have to node edit this because we've got to kick this in to get out and around. We have to kick this in to get out and around over here. So let's measure what that's going to be. We're going to want to be from down here, 14-inch up. So this guideline, 14-inch negative. So new, negative 14, create new guide. I'm going to go check the other side now over here and see what accommodation needs to be made. So this guide is going to be relative positive 14, create new guide, close. Now we need to node edit this because we have to notch. There's actually one more guide that we need. So we're going to need to come up 4 1/4 from this guide, relative 4.25, create new guide. Okay. Let's try to node edit this. That looks like a good profile. And again, we have to notch out and around all of this to get around our pipe over here. Now, the issue is the conduit that's going from the control panel to the VFD, I believe. I'm going to notch out around that as well. That's going to be over in this corner. So we'll add a couple of nodes. So we're going to want to come with a relative, create new guide, relative 5-inch, bring that back, close, 5-inch down, and then how far over, we'll have to measure that. -5. Now that'll get us around our conduit that's running. And the only other issue we have are the bolts that are hanging off, bolt heads, I should say, that are hanging off here. Yeah, we're going to make an accommodation for that as well. I know it's 1/2 inch, and then I think it was 2-inch. We're going to come up here, -2, create, and then 1/2, relative 0.5, create, close. Now let's node edit this. Let's do the same trick up here. Now we've notched around those bolts, and we're going to need to do it down here as well. Notching around our bolt heads and the fender washers, notching around our conduit, notching around our PVC. That's the profile. Now we're going to leave some big radius inside corners, but I've accounted for that. We're going to have 3/8 radius corners everywhere. But I don't have any trouble with that at all. And that is our profile. And in fact, I don't think there's anything else that we need to do. That's our profile toolpath. That's our pocketing toolpath. That's what we want it to look like. Obviously, we don't have to pocket in this area, so I could very easily just change that. Yep. Okay, so our pocket toolpath looks good. Our profile toolpath looks good. So all I did was change this to not run the bit down here, the whatever few maybe extra minute that it would actually take. We're looking good now. Next thing to do is to load up our bit because I know that I don't have the right bit in here. Well, we have to toolpath and then figure out what bit we're going to use. So let's move to that work. We will continue with creating toolpaths for this. Let's do that next.
You know what's worse than not remembering how to home your CNC machine? It's not participating in the Architectural Builder Supply March contest giveaway.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.